All right, so today we're going to continue graphing sine and cosine graphs. Only now we're going to take a look at what happens as these guys start shifting around the coordinate plane. All right, so we've taken a look already at what happens when the amplitude changes and the period changes and all that kind of stuff, but it hasn't really moved around. It hasn't really transformed. So we're talking about transforming these guys now. Right, and so that's what happens when we start adding and subtracting constants to or from this function instead of just multiplying, right? So far, we've been multiplying. The amplitude is right here, comes from A, comes from the coefficient on the function itself, which coefficients get multiplied into things, right? Changing the period, which comes from 2 pi divided by b. This needs to be filled in a little bit more, where b comes from the coefficient on x, right? Which again, we've done already, and this is all multiplying numbers into our function. Now, if we add or subtract a constant to our entire function, that's going to give us a vertical shift. That's going to give us a vertical shift up and down, right? If we add or subtract a constant inside of our function, like this, it's going to give us a horizontal shift. And it's a lot like, if you think back to Algebra 2, if you remember graphing those parabolas in vertex form, right? Your vertex always came from h and k, right? K was outside the parentheses, so it's outside the function, and that was always the y-coordinate of your vertex. And so if you remember, we graphed our parent function for our parabolas, came up with the new vertex, and then moved all the points according to how the vertex moved. And so that outside number always gave us our up and down shifting, right? And if you remember, the k out there moved the graph the way that it logically should have moved. Like if k were positive, it moved up. If k is negative, it moved down, right? Now, h always gave us our x-coordinate. So anyway, come back to that, and k is like this c out here. We're adding something to the entire function or subtracting something, and the way that it shifts is logical, right? If c is positive, it shifts up. If c is negative, it shifts down. This d, or adding or subtracting inside the function, is like this h, where we added or subtracted inside that parabola. That h was our x-coordinate, so it gave us our horizontal shift. But what was weird about it was that we always shifted opposite of what it looked like. A positive h means we shifted to the left. A negative h means we shifted to the right. Well, if you see, the same thing happens for d here, right? Since we're adding or subtracting inside the function, that means that if d is positive, then we're going to shift to the left, and if d is negative, we're going to shift it to the right. So it's going to be opposite of what we think, right? So let's apply all of that to some graphs. So here's the first guy, y equals cosine of x minus pi over 2. And so like I said, we're going to want to sketch out a parent function and then shift those points like we did for the parabolas back in Algebra 2. Well, the parent function is going to come from stripping away anything that's being added or subtracted to our function. So this minus pi over 2, we're going to ignore for a second. And so just graph cosine, y equals cosine of x, right? And so everything, we've been doing this for the last two homeworks. So amplitude is 1. The period is still going to be 2 pi because b is still 1. We're going to break that 2 pi up amongst 4 tick marks. So now every tick mark needs to be worth pi over 2. Okay. Now, if you still need the table, fill in the table. But at this point, we should know that cosine is going to start off of 0. So right here, it's going to start at positive 1. And then every tick mark, it's going to follow the cosine pattern, right? So the next tick mark, we're going to be at the x-axis. The next one, we're going to be at negative 1. We're going to come back up to the x-axis and then up to positive 1. Now, we do need to label the x-axis. So this first guy is pi over 2. Next guy is pi. This next guy is 3 pi over 2, and the last one is 2 pi. And then we want to sketch this in. Okay? Oh, sorry. This is a parent function that we're going to shift, so we need to dot this in. And it's going to be helpful to go ahead and finish out the pattern in the other direction. Let's get a couple of cycles in here. Right? So there's 2 cycles of this cosine graph. Now, our actual function has the minus pi over 2 in it, so we got to bring that back. Now, that tells us, this minus pi over 2 tells us that we need to shift to the right. And because it's a horizontal shift, it really, how far we shift it depends on what our period is, right? So we're going to shift it to the right, pi over 2. And since every tick mark is worth pi over 2, that basically means we're going to shift it to the right 1 spot, right? So every point gets moved over to the right 1, right? So this guy gets moved over, this guy gets moved over, so does this one, this one, this guy, this guy. So now we're just following a pattern, and we get a new curve that looks like that. Okay? Again, we shift it to the right because we're subtracting. Okay? And that's it. We're done. Right? We could still talk about our domain and range if we wanted to, which our domain is still going to be negative infinity to positive infinity. Our range now bounces still between -1 and 1, which we didn't label on our y-axis, and we should have. Okay? So there you go. Next one. Looks like this. So anything that's added or subtracted gets scribbled out for a second. And now let's just graph y equals 3 sine x. Amplitude now is 3. Period for this guy is going to be 2 pi over b. Well, b is 1, right? So it's just 2 pi over 1, which turns into just 2 pi. Okay? We're going to break it up over 4 points. And so pi over 2 is what every tick mark is going to be worth now. And so we go graph. We want to label 3 up here, -3 down here. And then sine starts at 0. And we know that's going to go, the next tick mark's going to go up to 3. The next one's going to be back to the x-axis. Next one's down -3, and then right there. So to label this, just be pi over 2, pi, 3 pi over 2, and 2 pi. And now dot this in. This is just our parent function. This is not our actual function. Right? And then to come back the other way to get our second cycle in. All right? Now, we got to bring back what we scribbled out and deal with that. So now we're going to add 3 pi over 2. And to do that, that means that we're going to shift to the left. Because we're adding, we're shifting to the left. And since every tick mark is worth pi over 2, and we're adding 3 pi over 2 to every angle measure, that means that we're going to shift to the left 3 spots. Because you have to add pi over 2 to itself 3 times to get 3 pi over 2, right? So that means every point gets moved to the left 3 spots, which means that one, which falls off the window, that one falls out of the window, and this one falls out of the window, so you kind of lose those points. So the first one that you can actually graph is this one. It gets pulled over 1, 2, 3 spots. Now, you can pull over every other point if you want, but this is going to start following our sine pattern. Right? So that one's going to be 0. Next one's going to be here, then here, then down here. Okay? So there's your new graph. Hopefully that makes some sense. All right? One more, and then I'll turn you loose on one. All right. So let's take a look at this guy. Again, scribble away the pi over 2 and just graph y equals negative 2 cosine x. Amplitude is negative 2, period. B is 1, so 2 pi over 1 is just 2 pi. And then we're going to spread that out over 4 tick marks. So everyone's worth pi over 2. All right. Sorry. Amplitude is positive 2. But A is negative. So cosine graph starts off of 0. So we go here negative 2 first. And then we go up to 2, then down to negative 2. So let's label everything. This is 2, negative 2. Our tick marks are our normal ones. And then dot this guy in as the parent function. Sorry about that. And we dot down here. Okay. Now we bring back what we scribbled out. And since we're adding pi over 2, that means we're going to shift to the left. And because every tick mark is worth pi over 2, it means we're just going to shift left 1 spot. So everybody moves over to the left 1 spot. You got to really pay attention and keep things straight, or follow the pattern, right? And so there you go. Okay, we didn't talk about it on the last one, but here, domain is still negative infinity to positive infinity. Range now changes. Now we're bouncing between negative 2 and 2, right? So that's our range. Okay, all right. Next one looks like this. Go ahead and give this one a shot. Stop the video, take a couple of seconds to graph it out, and then I'll show you what you should have gotten. All right, here's what it should look like. All right, so scribble this out. Amplitude is 4, period is 2 pi, so spread out over 4 tick marks. Every tick mark's worth pi over 2. So y equals 4 sine x is what you get with the yellow dots, right? And again, you can always complete this. Going the other way, probably would be a good idea. Now, it wasn't dotted in here, right? But those points we are going to shift, and maybe the dotting in we don't need to do either, but those points need to be shifted. Because every tick mark is worth pi over 2, that means that every dot needs to be shifted to the right, because we're actually we're subtracting, so we got to do the opposite. So we're shifting to the right 3 tick marks, right? 3 sticks. And so that's where the red points came from, and there's our graph. Okay? Hopefully that makes sense. If it doesn't, you got to come in and see me. All right? Now, let's talk about what happens when we add or subtract a number on the outside of the function, like this. So again, we're still going to ignore whatever's being added and just graph our parent function. Amplitude is 2. Period here is 2 pi, because b is 1. Divide that over 4. Every tick mark is worth pi over 2. Now go graph. So this is 2. This is negative 2. This is a sine function, so we start at 0, and then we just the sine pattern, right? So this is pi over 2, pi, 3 pi over 2, 2 pi. And then come back. I'm going to leave the dotting out this time and see how that works, if it works any better. Okay, now we're going to bring back, and we see that we're actually needing to shift everyone down, right? So this is like your k. This is outside the function. So this is moving vertically. So we want to pull every point down 3. Right? This gives us a shift of down 3. Which means we kind of have a new axis. So our x-axis kind of shifts down to -3 on the y-axis. Don't want to call it the x-axis anymore, though. So the wave should kind of come across symmetrically over that axis, right? So every point gets pulled down. So if it was on the x-axis, the point should now be on this new axis. And if it was above it, you just go however far above it was, right? And so this point is going to get pulled down quite a bit, so we got to make a new kind of set of tick marks here. And then we're back to here, and then we're back up to 2, and then we're back to boom, boom, and boom. And then we can put our wave in. Okay? I think the dotted horizontal line helps. You kind of treat it like an x-axis, where if the points are on the x-axis, then you can bring the points down to that. And if they were off the x-axis, you can just count that many spaces away from our new axis to get our new points. Okay? And that's it. That's all there is to it. So look at another one really quick. Here's a cosine graph. So again, we're going to scribble out the fact that we're subtracting a -1 here. And just do this as the parent function. So our amplitude is 2, but it is negative. Keep that in mind. It's going to matter. The period is going to change now, right? It's the first one we've had to change. So 2 pi over 5. So this is the period. Now to come up with how much each tick mark is worth, we got to divide that by 4, which means we got to flip and multiply by the reciprocal, 1 over 4. So we get 2 pi over 20. Which turns into pi over 10. So now every tick mark is worth pi over 10. Label. So we go 2, -2. Now cosine starts off of 0. Here it starts at -2. And then we follow our pattern. Okay, up here. Okay, now label your x-axis. Now every tick mark's worth pi over 10. So pi over 10. The next one would be 2 pi, and if you need to write that out, you can. Pi over 10. Next one would be 2 pi over 10, or pi over 5. So this guy's going to be pi over 5. Oh, pi over 5. And then the next one's going to be 3 pi over 10. Which can't reduce. And the last one's going to be 4 pi over 10, or just 2 pi over 5. So 2 pi over 5. All right, now we're shifting, and we're going to shift down 1. So we're going to make a new axis and shift every point down 1. Or, like I said before, if the point was on the x-axis before, it's now going to be on the dotted axis. And if the points were not on the dotted axis or on the x-axis, then we're going to just be that far away from the new dotted axis. Which I don't know if that makes any sense. So just pull down all the points by 1. So we're going to go down here, down here. This guy goes down 1. This guy goes down 1, and this guy goes down 1. And so this is your new graph, okay? And again, I did dot in the parent function, it's habit. I'm going to try to not do it in the next one, see if it's any cleaner. Domain here is still negative infinity to positive infinity. Now look at the range. What values is the blue graph bouncing between, right? And it's bouncing between -3 and 1 on the y-axis. So that's your new range. Okay? All right. The next couple I'm just going to let you try, right? So stop the video, try graphing this guy. You can start it back up and see see how it went, right? So here we're going to actually do 2 shifts at once. So see how good you are. Stop the video and I'll talk you through how to do it. All right, so we're going to scribble away everything that we're adding and subtracting. So that means we're going to graph 2 sine x. So amplitude is 2. Period is 2 pi, because b is 1. Divide that over 4 points. Every tick mark is worth pi over 2. Okay, sine starts at 0. And then we go up to 2, back to the x-axis, down to negative 2, and back to the x-axis. Label these. Pi over 2, pi, 3 pi over 2, and 2 pi. And then you can always come back the other way just to complete a second cycle. And I'm not going to dot this in. I told you I wouldn't. Okay, now, how are we going to shift every point? So bring back what we scribbled out. The negative 3 there says that we're going to shift everything down 3. The positive pi over 2 right there means we're going to shift left. And since every tick mark's worth pi over 2, left 1. So every point is going to go down 3, left 1. That means that point is going to be out of our window. Now, since we are going down 3, we do make a new sort of horizontal axis right there. And so if the point was originally on the x-axis, it's going to be on that dotted axis down there now, but it's going to be shifted left to 1 spot, if that helps you keep track at all. Otherwise, just count them out, right? So this point right here is going to go down 1, 2, 3, and left 1 and end up right here. The next point is going to go down 1, 2, 3, left 1, and end up right here. The next point is going to go down 1, 2, 3, and left 1 and end up right here. But then we're going to come back up. And then into here. And then here. And then here. And then here. And then here. And this becomes our new curve. We would actually yeah, so this is the one that was not in our original graph that's there now. Okay, try this real quick. Domain here is going to be negative infinity to positive infinity, right? And then the range. Okay, are you thinking about this? Now we're bouncing between, and we didn't label our y-axis, shame on us, but we're bouncing between negative 1 and negative 5. So negative 5 to negative 1 becomes our range. Okay? All right. Hopefully that made enough sense. Enough for you to try the next one, right? Give it a shot. Stop the video, work it out, start it back up, and I'll walk you through it. Okay, scribble this out. Scribble this out, and we're graphing negative 3 cosine x. So amplitude is 3. Period is back to 2 pi. Divided by 4, pi over 2. Every tick mark's worth pi over 2. Now let's go graph negative 3 cosine x, right? That means we're going to start at negative 3, then go here, here, okay? Now, label everything. This is 3, negative 3, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? I'm not going to label, or I'm not going to sketch in the dotted graph. I know that we talked about it a lot, and I told you should, but I think that might just make it more confusing. So what if we leave it out if it's a little bit easier to see? So there's our parent function graph. Now we got to bring everybody back in, figure out how we're going to shift this, and get our new points. So because of this 4, we're going to shift everybody up 4. And because of this minus pi, we're going to shift everyone right. But how many spots? Since every tick mark's worth pi over 2, I need 2. I got to shift it 2. So to the right 2. Every point goes up. So we're going to actually do a new horizontal axis right here, which means that some points should end up on it. Right? So this guy way down here is going to go up 1, 2, 3, 4, and go right 1, 2, and end up right there. Next point's going to go up 1, 2, 3, 4, right. Yeah, that's right. Sorry. 4, right, 2 puts this right here. Okay. This guy is going to go up 1, 2, 3, 4, right 1, 2, and end up right here. This guy's going to go up 1, 2, 3, 4, right 1. Let's see. Did I do that last one wrong? Yes. Sorry, this last one should be on the y-axis. It's hard. It's tough to keep track of. Go up 4, right 2, puts this right here. Next point, which is right here, needs to go up 1, 2, 3, 4, right 2, and end up right here. This point goes up 1, 2, 3, 4, right 1, 2, and ends up right here. This point goes up 1, 2, 3, 4, and right 1, 2. And that'll be about as much as we can get on here, this way. Of course, the next tick mark over here should be here, and the next one should be here. And so that's what your graph would look like after it's been transformed. Okay? You could talk about domain and range. Domain's still going to be negative infinity to positive infinity. The range, now our graph is bouncing between 1 and 1, 2, 3, 4, 5, 6, 7, right? So 1 to 7. Okay? All right. Then you've got one more, right? One more. So stop the video, try to graph it. I'll show you what it should look like. And after that, if you have any questions, come find me and I'll talk you through it. Okay? And there you go. Your last graph should look like this. Okay? Parent function, amplitude is 2. Period is 2 pi. Divide by 4. Every tick mark is worth pi over 2. So that means we're going to shift everybody down 1 and left, yes, 3 pi over 3, which basically means 3 tick marks. Okay? All right. Knock out the homework. If you have any questions, come find me.